Hello everyone. In part 1 of this topic, we covered the ampacity of multi-conductor cables installed in cable trays and when adjustment factors need to be applied. In a separate video, we examined section 392.22b to understand the cable tray width and installation guidelines for single-conductor cables. In this video, we will focus on section 392.80a2, which explains how to determine the ampacity of single conductors rated 2000 volts or less when installed in a cable tray. Let's dive into the topic without further delay. Section 392.80a2, Single Conductor Cables. The ampacity of single conductor cables shall be determined as permitted by 310.14a2. The adjustment factors specified in 310.15c1 do not apply to the ampacity of cables in cable trays. The ampacity of single conductor cables, or single conductors bundled together, triplexed, quadruplexed, etc., rated nominally at 2000 volts or less, must comply with subsections 392.80, A2, A through A2D. The ampacity of single conductor cables must be determined according to the guidelines set forth in section 310.14, A2. This section requires that the lowest ampacity be chosen when cables are exposed to different temperature zones. For instance, a cable has an initial ampacity of 270 A at 30 degrees Celsius. In an electrical room at 24 degrees Celsius, the ampacity increases to 382.5 A, while in a production area at 45 degrees Celsius, it decreases to 191.7 A. Following section 310.14, A2, the lowest ampacity, 191.7 A, must be applied for the entire circuit to ensure safe operation. Therefore, when evaluating the ampacity of single conductor cables in cable trays that are exposed to varying temperature conditions, the guidelines in section 310.14, A2 are essential. Additionally, the adjustment factors outlined in section 310.15, C1, for current carrying conductors do not apply to single conductor cables in cable trays. This is because section 310.15, C, addresses derating factors based on table 310.15, C1, which applies to conductors that are tightly grouped together, specifically when there are more than 3 conductors. In a cable tray, single conductor cables should be installed in a single layer or bundled in configurations such as triplex, 3 conductors, or quadruplex, 4 conductors. These arrangements allow for better air circulation and heat dissipation. This is an important distinction, as heat buildup among conductors in a cable tray is less of a concern compared to situations where conductors are tightly packed, like in conduits. Furthermore, the ampacity of single conductor cables or conductors bundled together with a nominal voltage rating of 2000 volts or less must comply with subsections 392.80, A2, A through 392.80, A2D. Subsections 392.80, A2A. When installed according to the requirements of 392.22b, the ampacity for single conductor cables of 600 kcmil and larger in uncovered cable trays shall not exceed 75% of the ampacities listed in table 310.17 and table 310.19. If the cable trays are continuously covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity for 600 kcmil and larger cables shall not exceed 70% of the ampacities in table 310.17 and table 310.19. Table 310.17 is for single conductors for free air and wiring installed in a 30 degrees Celsius, 86 degrees Fahrenheit, ambient temperature, while table 310.19 is also for single conductors for free air and wiring installed in a 40 degrees Celsius, 104 degrees Fahrenheit, ambient temperature. Since table 310.17 and table 310.19 list the ampacities of single insulated conductors in free air, does this mean that conductors in a cable tray are considered free air? To clarify, let's refer to the definition of free air in Article 100 of the NEC. Free air, as applied to conductors, an open or ventilated environment that allows heat dissipation and airflow around an installed conductor. Single conductors installed in uncovered cable trays are indeed considered to be in free air. However, because these conductors are placed closer together and may be in contact with surfaces that hinder airflow, The ampacity for 600 kc mil and larger conductors is limited to 75% of the values listed in Table 310.17 and Table 310.19. If these conductors are covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity for 600 kc mil and larger cables must not exceed 70% of the ampacities listed in Table 310.17 and Table 310.19. Let's use an example based on Table 310.17. A 600 kc mil XHHW single conductor cable has an ampacity of 690 amperes in the 75 degrees Celsius column. When these cables are installed in a cable tray according to Section 392.22b and uncovered, the ampacity is reduced to 690 amperes multiplied by 75%, resulting in 517.5 amperes. Please note that this ampacity is based on an ambient temperature of 30 degrees Celsius, 86 degrees Fahrenheit. If the cables are covered for more than 1.8 meters, 6 feet, with solid, unventilated covers, the ampacity is further reduced to 690 amperes multiplied by 70%, which results in 483 amperes. Now, let's determine the minimum width needed for a ladder-type uncovered cable tray that accommodates 5 circuits rated for 700 amperes, using RHW type TC single conductors. These cables will be arranged in a single layer. To identify the appropriate conductor size for the 700 amp circuit based on Table 310.17, we need to consider a maximum of 75% of the listed ampacities. Dividing 700 amperes by 75% results in 933 amperes. According to Table 310.17, a 1000 kc mil RHW conductor, which is rated at 935 amperes in the 75 degrees Celsius column, is suitable for this application. The outside diameter of the cables can be found in Chapter 9, Table 5 of the NEC, or the manufacturer's catalog. The outside diameter of a 1000 kc mil cable is 1.502 inches. With a total of 15 cables, their combined outside diameter amounts to 22.53 inches. To determine the minimum tray width, we refer to Table 392.22b(1) of the NEC, which outlines allowable cable fill areas for single conductor cables in ladder-type trays. Given the total outside diameter of 22.53 inches, the next standard tray width that can accommodate this size is 24 inches, 600 millimeters. Therefore, the minimum width required for the ladder-type cable tray is 24 inches, 600 millimeters. What if part of this cable tray is covered for more than 1.8 meters with solid, unventilated covers? What would be the necessary width of the cable tray? To determine the appropriate conductors, we divide 700 amperes by 70%, resulting in 1000 amperes. According to Table 310.17, a 1250 kc mil RHW conductor, rated at 1065 amperes in the 75 degrees Celsius column, is suitable for this application. According to Table 5 in Chapter 9 of the NEC, the outside diameter of a 1250 kc mil cable is 1.729 inches. With a total of 15 cables, their combined outside diameter is 25.935 inches. Based on Table 392.22b(1), the minimum width required for the ladder-type cable tray is 30 inches, 750 millimeters. Thank you all for watching.